Hello, friends. Let's give this a whirl. Try and be patient with me. I've never tried to record a video in my classroom before, so we'll see how it goes. All right. So hopefully some of this work we've been doing has been making sense to you. I would encourage you to do research on your own, and of course, email me with any questions you have. We've been working on geocentric diagrams or geocentric view diagrams shaped like this, and they can be kind of tricky at first. Can you see this all right? I hope so. I'll try adjusting the screen. Pardon me. Like I said, new at this. So, there's so much I wish you were here to tell me, or I could tell you about. There are always 180 degrees of sky is always visible. And we always look for the North Celestial Pole first, or NCP, the North Celestial Pole. And in Columbus, the North Celestial Pole is always 39.21 degrees above the northern horizon in Columbus, because Columbus has a latitude of 39.21 degrees north. So we're literally almost 40 degrees of latitude north of the equator. I'm worried you can't see this. I'm going to try turning out the middle lights. Bear with me. Is that better, friends? Maybe, perhaps. We can't do it in the dark. So, here's the trick with the North Celestial Pole. And you always, when you start these diagrams, this is the way to start it. Is to always look for your North Celestial Pole first. And the North Celestial Pole location is always equal to the latitude of the observer's location on Earth. So yesterday in class, we drew some of those diagrams. And we drew one for the equator. Now at the equator, the North Celestial Pole, because you're at 0 degrees, is at the north horizon, or 0 degrees above the horizon. That puts your celestial equator at 90 degrees to the North Celestial Pole. Always. The equator is always 90 degrees from the pole, whether it's the South Pole or the North Pole. It's always 90 degrees from there. So that puts the celestial equator at zenith, or directly above the observer. Let's put the observer in. I hope you can see this. I hope this is helping. Remember, zenith is the point directly above the observer's head. So if you're at the equator, the celestial equator is at zenith. And this line, the Tropic of Cancer, is 23.5 degrees from there, always. And this line, the Tropic of Capricorn, is always 23.5 degrees south of the equator, or celestial equator, either way. So it would be here on the globe. Well, this would be the Tropic of Cancer. And this one, the Tropic of Capricorn. So you're going to draw those in these arcs. Now this line we added in because there was some question about it. This again is the ecliptic, or the plane of the solar system, or the apparent path of the sun through the year from Earth's position. Then we drew another diagram like that for the North Pole. Now the North Pole is at 90 degrees. So that means the North Celestial Pole is directly overhead. I mean, if you're standing at the North Pole, boom, it's right over your head. And it still points at that star Polaris, the pole star. So that puts the Tropic of Cancer completely visible, and the Tropic of Capricorn not visible at all. And again, that ecliptic runs between the two. The trick with being at one of the poles is that every direction is the opposite direction. So if you're at dead center at the North Pole, every direction on your diagram is south. It has to be, because every direction for the North Pole is south. Then we started to work on diagrams for different, I didn't mean to come off camera there. More about it. We started to work on diagrams for different places on Earth. And that's a big chunk of your assignment. In fact, that is your assignment. I want you to draw 3 diagrams for different latitude locations of your choosing. And then decide whether it's noon, sunrise, or sunset, and on what day. Remember that let's just use this one for the equator. Noon is where the sun crosses the meridian. So if it's noon on the winter solstice in the northern hemisphere, the sun is here. If it's sunrise on winter solstice, the sun is here. And if it's sunset, it will be here on the western horizon. Maybe I'll bring the computer closer to this diagram so you can get a better look at it. Bear with me, here we go. Pardon me and not having a face. Here we go. Does that help? Maybe. Let's go this way so you can see all these notes a little clearer, maybe. Yikes. And then there's this one and these diagrams. Back up just a little. So this diagram here is for noon on the winter solstice at 23.5 degrees south latitude. And we're looking at the south celestial pole. What I'd like you to do is attempt to draw 3 of these diagrams on your own for different latitudes. And I'll write it up in a little assignment and post it with this video as well. Again, I really appreciate your patience with me and this work. And I miss you all. Several of you are going to be returning students that I hope to see at some point. What I'd like to do is find a day after school, maybe one next week or every other week, something like that, where we can get together. And you can come in after school. I'd be available after school for you. And we can sit and talk and work through some of these issues. So I hope you're well. I hope this video works. And if you need anything, well, you know how to find me. Good luck, my friends. Take care.